All right, let's go over how to do the first practice quiz, chapter 1 practice quiz. There's lots of ways to do some of these. I'll do it the way that makes sense to me. So just check, make sure you get the right answers. And again, there are multiple ways to think about this, but I'll show you how I think about it, and hopefully it makes sense. Okay, so we want to know the density in kilograms per meter cubed of a liquid with 92 pounds per foot cubed. So we got, everything is wrong about it, right? We got to change kilograms to pounds, and that's pretty, or pounds to kilograms, that's pretty easy, because we know that 2.2 pounds is 1 kilogram. However, from going meters to feet, I didn't give you a number for that, we got to figure it out, but we know that 1 meter is 39.37 inches, and a foot is 12 inches, so we can just use that. You don't even need to use this one, you could, but let's skip that one. I just told you that because it's fun to know, and you can use that, but I think we can do it a different way. So let's see how many feet are in a meter. Okay, so let's say you have 1 meter. So 1 meter, we want to change that. We know a meter is 39.37 inches. We put the 39.37 inches in the top because we want to be able to cancel out the meter. So meter in the top, meter in the bottom. We know we did it right. And then we want to change that to feet, so we know that, let's see, 1 foot is the same as 12 inches. Again, we know we did it right because the inches in the top, inches in the bottom cancel, so we put them in the right place. We make sure of that. We see meters cancel. All we're left with is feet. So we're on a calculator, we go 39.37 divided by 12. So 39.37 divided by 12. And I get 3.2808333333. I'll keep 3.2808. That's pretty good. So 3.2808 feet. Okay, so 1 meter is 3.2808 feet. Okay, what is a meter cubed? So 1 meter to the 3rd power, a meter cubed, because that's what we want, right? We want to get meters cubed. That's the same thing as 3.208 feet cubed. So we got to raise 3.2808 to the 3rd power. I'll do that here. And I get about 35.3. I'm going to round out. It's 35.31. I'm just going to keep 35.3. So about 35.3 feet cubed. And that's because 1 meter, a meter on a side, is 3.2808 feet on a side, right? So 3.2808 feet on a side, 3.2808 feet. If we want to find the volume of this in feet cubed, it's this times this times this, right? That's for the 3rd power, it ends up being 35.3 cubic feet. Now we're ready. We have 92 pounds per foot cubed. And we do our regular rule. We have pounds in the top. So we'll use this number here. 2.2 pounds is 1 kilogram. I know I put the 2.2 pounds in the bottom. 1 kilogram on the top. That way the pounds cancel. Left with kilograms, but we want meters, so we multiply by, let's see, this number's in the top, 35.3 feet cubed is the same thing as 1 meter cubed, and the foot cubed in the top cancels out foot cubed in the bottom, and we're left with kilograms per meter cubed, which is what we want, kilograms per meter cubed. So now it's calculator time, and I go 92 times 35.3 divided by 2.2. So 92 times 35.3 divided by 2.2 is 1476.18. 1476 is good enough. So about 1476 kilograms per meter cubed. There's other ways to do this, to think about this. I think this is the easiest way. And so, yep. Okay, good. Hope that makes sense. Let's go on to number 2. Okay, so number 2 says a spherical planet has a radius of 3372 kilometers and a mass of 6.42 times 10 to the 23rd kilograms. This would be a planet slightly smaller than the Earth. And I think I just made up these numbers, but it's pretty typical numbers. What is its density in grams per centimeter cubed? Most densities are given in grams per centimeter cubed. Water is 1. Water is 1 gram per centimeter cubed. Typical rocks are like maybe 3. You already did a problem with lead. It's like pretty dense, 11. The densest thing on Earth is like a little over 20. Okay, so over 20 grams per centimeter cubed doesn't really happen that much. Okay, so we want to know the density. So we know that density is mass divided by volume. Well, the mass is this, but we want it in grams. So let's change that. So the mass is 6.42 times 10 to the, okay, we want grams. If it's 10 to the 23rd kilograms, a kilo means 1,000 grams. So we just have to add 3 to the 10 to the 23rd. Add 3 zeros. This tells you how many zeros to add. We're going to add 3. So it's just 10 to the 26 grams. All we got to do is multiply this number by 1,000, which means adding 3 to the scientific notation. Okay, so now we have our mass. Now we got to figure out the volume. And first we got to change kilometers to centimeters. Okay, so 3372 kilometers. Again, kilo means 1,000. So we multiply by 1,000. That'd be 3372 with 3 zeros meters. We want centimeters. There's 100 centimeters in a meter. So we multiply this by 100, which means 2 more zeros. Why did I say times there? That should be equals. That's equals. And so that's equal to 3372000 with 2 more zeros centimeters. Put some commas there. 337,200,000 centimeters. Now we need the volume. It's a sphere. We already did a problem, density problem, where we use this formula. Spheres are 4/3 pi r cubed. So that's 4/3 pi times this big number cubed. Centimeters to the 3rd power. So again, make sure you can do this correctly on your calculator. It can be tricky to cube things. So 337,200,000 y to the x3 is how I did it on mine, times 4 times pi divided by 3. I get 1.60602. That's good enough. 1.606 times 10 to the 26th. 1.606 times 10 to the 26th centimeters cubed. Now we're ready to use this formula. So density is mass divided by volume, which is 6.42 times 10 to the 26 grams, divided by 1.606 times 10 to the 26 centimeters cubed. And this is awesome. Notice 10 to the 26 over 10 to the 26. They cancel. It's the same thing over the same thing. We don't have to worry about those. So we just have to go 6.42 divided by 1.606. So let me try that. And I get, that's about 3.997. That's practically exactly 4. So we'll just say it's about 4 grams per centimeter cubed. All right, so that planet has a density of 4 grams per centimeter cubed, which is pretty typical. The Earth's is a little over 5, about 5.5 grams per centimeter cubed. So that's, typical density for a planet. So those numbers are realistic. I don't always make the numbers realistic. Just kind of think I got lucky here and it kind of made sense. All right, that's number 2, 4 grams per centimeter cubed. Moving on to number 3. All right. Let's scroll down here. What does number 3 ask us? Let's see. Jacob runs 12 miles an hour. What is his pace in minutes per mile? Okay, so 12 miles an hour. If you're running that speed, pace is minutes per mile. It's upside down. Right here we have miles distance per time. Now we have time per distance. So first we got to change units, and then we just flip it upside down. Okay, lots of ways to do these and think about this. Whatever makes sense to you, but that's what makes sense to me. Let's change the units to minutes. Oh, the miles is good, right? Let's change the hours to minutes here, and then we just flip it upside down. Okay, so we have 12 miles per hour times, let's see, 1 hour is the same as 60 minutes. We did it right. Hours, top hours cancels. So this will give us miles per minute. So I go 12 divided by 60. I think that's 1/5, right? 12 divided by 60 equals 0.2, 1/5. Yep. So that would be 0.2 miles every minute. We want how many minutes per mile? So we just have to flip this upside down. So you go 1 divided by 0.2 miles per minute. 1 divided by 0.2 is 5. Mile stays in the bottom. Something in the bottom of the bottom goes to the top. So this would be 5 minutes per mile. So his pace is 5 minutes every mile. He is running a mile every 5 minutes. So that's 5-minute miles, which you could have seen right away. If you're running 12 miles an hour, that means it takes you about 5 minutes to run a mile, right? But sometimes the math isn't so easy, so you just do it this way. Again, there's other ways to think about how to do this, but this is what makes sense to me. So that's running 5 minutes every mile. Okay, that one is a lot easier. Let's move on. Backside here. All right, right is 1 fraction. Okay, this is common denominator time. This is just good algebra practice. We're going to be doing a lot of things like this. We have to have the same denominator. These denominators don't match very well, so we just have to multiply them together. Okay, so we have 3, we have to have x times x minus 1, so we multiply them together to get a common denominator, but if you multiply this by x minus 1, we got to multiply top by x minus 1. So I get from x minus 1 the top also. And again, we check, x minus 1's cancel, this is the same thing as 3 over x. So that looks right. Minus 5 over x times x minus 1. Here we multiplied the bottom by x, right, to get x minus 1, so we got to multiply the top by x. Again, x over x cancels, 5 over x minus 1, that works. Now, we can leave the bottom as x times x minus 1, or we can multiply it out. Either one is right, either one is about the same amount of writing. I'm just going to leave it, but if you multiplied it out to x squared minus x, that's fine, okay, it's completely right. There's no better way to do it. But we got to simplify the top. So on the top, we have 3 times x. So 3x minus 3, right? 3 times minus 1 is minus 3. Minus 5x. Minus 5x over x times x minus 1. So that is 3x minus 3 minus 5x. Let's see, the minus 5x wins. So we have negative 2x minus 3 divided by x times x minus 1. And that's about as good as you can get. There's no better way to simplify that. So again, you could change it to x squared minus x in the bottom, but that's as good as we can get. Okay, that's number 4. And almost done. So let's look at number 5 here. We want to solve for t. Okay, let's see. So, first thing we can do is put the 2 on the other side. Right, that simplifies things. If you subtract 2, it's a plus 2 over here. So we get 4 over 2t minus 3 is equal to 6. I always make my t's with a little curvy thing here because otherwise it looks like a plus sign. I suggest if your handwriting isn't crazy neat that you do that too. You have to always try to make sure your letters and things don't look like numbers. So to come up with tricks like that, yeah. Okay. Now let's see. Let's cross multiply. We'll multiply both sides by 2t minus 3. Okay, multiply this side by 2t minus 3. It cancels out over here. So I have 4 is equal to 6 times 2t is 12t. 6 times minus 3 is minus 18. Okay. Let's put the 18 on this side. It was minus on this side. It's plus on that side. So 4 plus 18 is 22. So 22 is equal to 12t. Divide both sides by 12. And I get t is equal to 22 twelfths. See, both of those divided by 2. 22 twelfths, which would be 11 sixths. Which is totally fine to leave it like that. You could get a decimal if you want. If we got a decimal, it would be, what, 11 divided by 6, be 1.833. It's actually better to leave it like this, okay? So let's just leave it as 11 sixths. Okay, I think that's it. The real quiz will have very similar problems, and I'll change the numbers. These equations will be slightly different, but very similar. So make sure you can do all these on your own. Practice doing them again, without looking at what I did if you needed help. Make sure you get the right answers, and then you should do well on the quiz. All right, thanks for listening.